Hi y'all. In this video, we will look at factoring a quadratic equation with leading coefficient 1. In our first example, we're going to try to factor z squared plus 12z plus 35. What we're going to end up with as a result is something that will look like this. Z plus m times z plus n, where m and n are both real numbers, in particular here integers. Now, it's important to recognize that in general, m and n can be either positive or negative numbers. So this might look like z minus 5 or something. But in general, we're looking to find out really what the values of m and n are here in this problem. That's what we're trying to do. We needed to know a couple things about m and n. And to see that, let's go and multiply this out by using the derivative property of multiplication over addition. If I multiply this, and some people call this rolling, multiply straight out, I should get z squared plus n times z plus m times z plus m times n. And combining that together, we'll get z squared plus m plus n times z plus m times n. And what that's really going to tell us here is that this term that's times n is always going to be of the form m plus n. And this last term is always going to be of the form m times n. So we're looking for two numbers, m and n, with those properties. That is, m plus n here is 12, and m times n here is 35. To help me do this, I'm going to make a chart. In that chart, I'm going to figure out the numbers that I can use to make m times n equal 35. And I'm going to make a list of all the ones I can think of. Now, what my goal here is to find those two values so that m plus n equals 12. But I'm going to first make this list of products. Well, one way to do that is with 1 and 35. With the value for m being 1 and value for n being 35. The sum there, m plus n, would be 36. And that's not what I'm going to want. Another set of products, of values that would work for the product, are 1 and negative 1 and negative 35. The sum there would be negative 36, not what I want. 7 and 5 will give me a product of 35, and their sum is 12. And just to make my list complete, the last two values that I can come up with are negative 7 and negative 5, and they give me negative 12. And hopefully you see here that the correct values for m and n that work here are 7 and 5 even. What that's going to tell us is that the answer to this question should look like this. Z plus 7 times z plus 5. And that's what you should get to factor a quadratic equation with leading coefficient 1. I'll add an equivalent way to write this would be to have z plus 5 times z plus 7. That would also be correct. And other formulation will work here. A great thing to do at this point would be to check and to multiply this out, and you will see that this yields the result that we want here. We'll go through a couple more examples, and we'll get back to it in just a second. In this second example, we're asked to factor the quadratic equation y squared minus 10y minus 24. Here, the product m times n is a negative 24. So we're looking for values of m and n that multiply together to give us a negative 24. And what we're really trying to do here is to find those values in such a way that they equal a negative 10. I'm again going to use a chart to do this. Some of you can do this without a chart, and that's great. If that works for you, well, please do that. But the chart will lead you to that. And I'm going to kind of go in order. I'm going to start with 1 as my value of n and determine what product with that gives me negative 24. I think that's a negative 24. The sum of those two values should be a negative 23, and that's not what I'm shooting for here. So I'll move on. For m equals 2, the other value I'd need for the product of negative 24 is a negative 12. My sum there would be a negative 10, and in fact that's the one I'm going to want. I'm going to circle that. To finish out what my list would look like if I kept going, let's keep going here. I would have 3 times a negative 8 with the sum of negative 5, 4 times a negative 6 with the sum of negative 2, And if I keep going, you're going to notice it gets kind of repetitive. 6 and negative 4 with a sum of 2, and so forth. This right here is the same values I had right here, just with the signs switched. Notice that when I switched those signs, I actually got a different sign over here with the sum. So this is useful to note. When this product is negative, I'm going to have m and n be different signs. So one will be positive and one will be negative. What our work has shown us here is that our end result for factoring this quadratic equation should be y plus 2 times y minus 12. I would again very strongly recommend that you multiply this back out to verify that it does indeed equal what we started with. We'll do one more example in this video. In example 3, we're factoring x squared minus 5x plus 6. Here the product at the end of what we're calling m and n is 6. So we're looking for two values that when multiplied together give us 6, and whose sum is a negative 5. So again, we're going to be multiplying numbers together to get us 6, and they're going to add up to a negative 5. The only way this is going to work to give me a negative sum here is if both of those values are negative. So my m and n, one possibility for that would be a negative 1 and a negative 6. Adding those up is a negative 7. That didn't quite work. Going on here, trying m equals a negative 2. The other value I would need for that product to get a product of 6 is negative 3, and that'll give me a sum of negative 5. And this is where I'm looking for. I'll say again, try circling that a little bit better. I'll say again, some of you will be able to do this without the chart, that's fine. But however you get there, you should end up with a result something like this. X minus 2 times x minus 3. And again, please do get in the habit of multiplying this out to verify that it's the end result. And in this case, that should be correct. Hope this video helps you to understand how to do this.